Hello, welcome back. The title of this lesson is called Combining Like Terms, and this is part 1. I'm incredibly excited to teach this today because it is really usually the first lesson in math sequence that really starts to give students a hard time, and it looks really difficult, and a lot of roadblocks go up often with students with this kind of stuff. But I'm here to tell you, just take a deep breath. I promise you I will make it incredibly easy. Anyone can do this material, no matter what you might think ahead of time. Combining like terms, what does it mean? It's easier to show you than to tell you. So let me write an expression down. 3 plus 4 times h plus 2 times h. All right, so what do we have here? First of all, we have a number, that's just a number, and we're adding it to a number, but also with a letter right next door. Now you need to get used to seeing this. When you see a number right next to a letter, it means they're multiplying together. We don't have a multiplication symbol between them. You know, the x, we definitely don't use x's because we're using variables that are x's also sometimes. And we don't put the dot between numbers and letters either. But you need to know that when you see a number right next to a letter with no operation, it means they are multiplied always. And you need to kind of get used to seeing that. So we have 4 times h, and then we're going to add to that 2 times h. All right. Now, what does it mean to say that we have like terms? When we have like terms, it just means that the variable, whatever variable you have, they both match. If the variables match, then we say that those terms are similar or they're like terms. And when we have like terms, we can add them together. All right. Now notice that this term is just a number. It doesn't have a letter. So you cannot add it to the 4h. You know, a lot of students try to just add the numbers together, but here's the deal. You can only add the numbers together if the terms match, or if we say, another way of saying, if we have like terms. Only then can you add or subtract the terms together. So what we have here is we have a situation where we want to add the 3 to these things, but these other terms are totally different, right? So we really can't add the 3 to these. We can't. We want to, but we can't because this term has an h, but this one doesn't. But if we look at these two terms, they both contain an h. So we have 4 of these h's, because it's 4 times. We have 4 of these h's here, and we have 2 more of these h's here. And so because we're adding h's to h's, we can add the numbers in front. 4 plus 2 means we actually have 6 of these h's. And this is the final answer. Now, oftentimes when we write these expressions down, not always, I may forget to do it myself, but most of the time, we really want to write the term with the variable in front and the term that are just numbers at the end. You don't have to, but often we do. So really, this is the same as 6h plus 3, 6 times h plus 3. So here, when students look at this kind of problem for the first time, a lot of students just completely shut down and they don't want to look at it. It looks too frightening, too scary. But I need you to take a deep breath because all of these problems will be like this. Literally, all you have to do is look at the terms that have the matching variables, and if they match, then you can add them. If they don't match, you can't add them, no matter how much you want to, and you also can't subtract them either, right? Let me explain why this is the case. All right, if I have a bag of apples here, and I have another bag of apples here, I have some apples here and some apples here. So I can add the apples. Let's say I have 2 apples here and 3 apples here. I can add them. I'll have 5 apples. It's apples to apples. I add them together. I get a total of 5 apples. In this case, I have 4 h's. We can call them apples though. And here are 2 more of these h's, but we can call them apples. It's easier to think about. So 4 apples and 2 apples, I can add them together. I will then have 6 apples, right? Because these are like terms, I can do that. But what if I had oranges here, 2 oranges, and then 2 apples? You might want to add them together, but you really can't because you're literally adding, or you would be trying to add apples plus oranges. Now, the smarties out there might say, well, I can add 2 apples and 2 oranges, and I'll just get 4. But you see, when you do that, you're not adding apples to oranges, you're adding fruit. Because apple is a type of fruit and orange is a type of fruit. And together you would have 4 pieces of fruit, right? But you really cannot add apples to oranges because they're different. So in terms of in math and algebra, when you add things together, the only way you can do them, or if you subtract them, the only way it can happen is if they are of the same type, essentially. Apples plus apples. Cucumbers plus cucumbers, eggplants plus eggplants, whatever you want to think about. Basketballs plus basketballs, pizzas plus pizzas. You can only add or subtract them if whatever it is you're talking about, the variables match. If the variables are different, or if you just have a number here, which is also different, then you cannot add them. So it looks a little funny that our answer is going to be 6h plus 3, because until now you always try to get a single answer, but in higher math like algebra, if the variable does not match, then you cannot add these any further. You cannot add them. You just have to leave it with the plus sign. All right, as always, the first problem takes the most explanation. And now we need to march on to the second problem, and you will see very quickly how this works out. Let's say we have 2b minus 5 plus 3b. Now, which ones are the like terms? Well, I have a b term here and a b term here. This is like apples and apples, so I know I can add these together. I have a minus 5 here, but I really can't combine it with anything because this is a constant term. It doesn't have a variable, and the only way I can add terms together is if the variables match. That's the only way I can do it. Apples plus apples, you know, cars plus cars, ships plus ships. I have to have them match. Now, these are way apart from each other. I can add them in one step if I like, or I can just take a minute to rewrite what I have here. And you don't have to do this, but you can in the beginning. I still have the 2b, and plus the 3b, I can move it next door because I can rearrange these terms. And the minus 5 can then go to the end. You see, when you're adding or subtracting numbers, you're totally free to move the order of them around, right? Because when you're adding things together, it doesn't matter the order that you add them. 2 plus 3 plus 5 is the same as 5 plus 3 plus 2. And you can rearrange the orders any way you want, and you still get the same answer. So it's totally fine for me to take this plus 3b and move it right behind with this plus 3b and take this minus 5 and put it at the end, because the order in which I do the additions and the subtractions really won't matter in the end. But now that they're right next to each other, it's very easy for you to see that apples plus apples, I can add them. 2 apples plus 3 more apples will give me 5 apples. Of course, the variable is b that we're talking about. The minus 5, I really can't do anything with it because there is no variable here, and so I cannot combine it with anything else. And so even though it looks a little weird at first, because up until now, you always want a single answer for everything, fractions, decimals, addition, division, you always want one answer. But in algebra, sometimes the answer has a plus or a minus sign, and you can't do anything with this. You can't combine them. So that is the final answer. And usually we write the variable first and the constant term right next to it, usually. All right, let's pick up the pace just a little bit. What about 14 cats, let's say C for cats, minus 9, minus 5 more cats? So I want to combine like terms. Obviously, which terms are the same? C, the variables match, so I can combine them. The 9 I can't combine with anything, so it's going to basically stick around. So I can rearrange this, so 14C, and I want to move this 5C term right next door. But notice in front of the 5C is a minus sign. That has to come with it. The operation that you're doing on the 5C has to come with it. Otherwise, you're not going to get the right answer. So you take it with it. The minus 5C comes with it. And then the minus 9, the operation comes with it also. So this one we tucked in right here, and this one we tucked in right here. You don't have to do this, but putting them next to each other makes it very easy. 14 cats minus 5 more cats. You're going to get 9 cats. And then this minus 9, see, all we did was subtract these. The minus 9 is still there. So there you have 9C minus 9. This is the final answer. Of course, you want to subtract these numbers in the beginning, but you can't, because here it's 9 cats, and here it's minus 9 nothings. So they're different terms. You cannot combine them because you cannot add or subtract any terms unless the variables match. That's a rule. I'm going to say it over again, over and over again, until you just remember it. What about 37J plus 12J? Well, do I have like terms? Yes, I do. I have a J term here and a J term here. So when the terms match, I can then just add the numbers together. And what is 37 plus 12 anyway? That's going to be 49. So I'm just literally adding the numbers together, and the variable comes along for the ride in the answer. It would be like 37 jumbo jets. The variable J stands for what it is you're adding. jumbo jets. And then you have 12 more jumbo jets. So when you add them together, it's like you have 49 total of whatever J is, which is a jumbo jet. Now, in real life, J doesn't stand for jumbo jets. It's a number, right? But you can think of it as a placeholder for an object to help you remember that when you add or subtract things, you have to be adding the same objects together. That's just a rule you're going to have to get used to, and you will get used to it as we go along. All right, what about 18 plus 25 times y plus 17 times y? Where are my like terms? You see, I have a y term and a y term. So I can combine those, and they're already next to each other, so I can just combine them, right? 18 I can't combine with anything because it's a constant term. There's nothing else here. Now, what is 25 plus 17? Well, you add 10 more is 35, and then 7 more is going to be 42, right? So here you have 42, and you have to carry that variable with it because it's like 25 balls of yarn and then 17 more balls of yarn. So of course, when you get 42, you have to carry around the balls of yarn to tell you what it is you're talking about. Now, usually we want to write the variable term first, 42y plus 18. I mean, either one of these answers is the same because when you add numbers, when you add anything, it doesn't matter the order. But usually we want to write the variable term first and then any constant terms after that. So 42y plus 18. All right, believe it or not, that was the halfway mark. We're cruising right along, and by now, hopefully it should be a little more clear what we're doing. What about 7 plus 5 times t minus 2 minus t? So where are the like terms? Well, I have a t term here and a t term here, so those are going to be like terms. But notice in this one, I have a constant number here and a constant number here. These are like terms. These are like because the same variable is present, but these are like terms because in both of them, there's no variable present. So if there's no variable present, they still match, and we can add them or subtract them as needed. Now, to make it easier, we're going to rearrange what we're doing, right? Let's put the 7, let's leave the 7 in place. But the minus 2, that like term, let's move it right next door. We have to carry the operation with it. So the minus 2 gets tucked over here. And then we have this operation, the plus 5t comes from here. And then the minus t at the end, that like term, we'll just drag it right down here. So when you're rearranging terms, you have to drag the terms in place, but also the sign comes with it. The operation that's directly in front comes with it as well because it's part of the term. So the 7 stayed the same, the minus 2 came here, the plus 5t came here, and the minus t, we just left it at the end. And we did that to put the terms right next to each other. So these are like terms, we can subtract them. 7 minus 2 is 5. And then these are like terms. We have positive 5t minus t. Now you might say, well, wait a minute, what am I subtracting here? 5t minus t, what is that? Well, when you see a variable by itself, right? I'll go over to the side here. When you see a variable by itself, like t, that is exactly the same thing as the coefficient 1 being in front, 1 times t. If you see a variable here and a variable, then you might say, what's the coefficient? Well, there's an invisible 1 there because 1 times t is the same thing as t. So anytime you just see a variable with no apparent coefficient, the coefficient's there. It's just an invisible 1. We don't always write the 1. So really what you have here is you have 5t minus 1t. 5 minus 1 is 4. So it's going to be a positive 4t because 5 minus 1 is 4. So the plus sign here is from in front, and then you have 5 minus 1 is 4, and so you have 4t. Usually we want the variable terms first, so we'll write it as 4t in the front plus 5 at the end. The 4t is positive, so we can put it in front. We don't have to write the positive symbol. We know it's positive. This 5 is a positive 5, so when we write it at the end, we can just put it as plus 5. That kind of stuff comes with experience and practice, but you just need to know that every term in an expression has a sign associated with it, right? The sign of this is a positive. So when I put it in front, I don't have to put a plus, because if there's no plus in the leading term, I know it's positive, right? But with this one, when I put it at the end, this invisible plus that's here has to come with it because it has to have some sign with it. You have to pick plus or minus to join everything together. So this, because it was a positive 5 in the front, becomes a positive here. So 4t plus 5 is the same as 5 plus 4t. Those are exactly the same things, and so this is the final answer. All right. Let's take a look at something larger. What about 15 plus 4 times d minus 6 minus 2 times d plus 8 times d? So we see that we have a constant number here and a constant number here. Those are like terms. And then we see we have a d term here and a d term here and another d term over here. So those are all like terms. Now, in order to make it easier, we're going to lump them all together. First, we can just leave the 15 in place and write its companion term right here, of course taking the minus with it, so minus 6. Then we have a plus 4d, we can just write that down here. And then here we have a minus 2d, the minus sign has to come with it, and then the plus 8d has to come with it. Literally all we did is move this here, the minus 6 can come here, the 4d can come here with the plus sign from here, the minus 2d comes here, the plus 8d comes here, and now everything is grouped together. 15 minus 6 is 9. Those are like terms, so I can combine them. Now here, there's a couple of things you can do. You can add and subtract them all at once in your head, going left to right, or we can just do it one step at a time. We have the 4d minus 2d. Ignoring this, if we just did this, 4 minus 2 is 2d. But then we would still have this left over, so we have to do that in the next step. And so then we would have 9. We have 2d, here, positive 2d plus 8. 2 plus 8 is 10, so plus 10d. And now, of course, we want to write all of our terms with the variables first, so it would be 10d plus 9. 10d plus 9, that's the final answer. Really need you to study this stuff. It looks like maybe you want to just blow through it sometimes to kind of get to the next problem, but really, it's more important that you understand exactly what we're doing so that when the problems get a little harder later, or maybe just longer, then it won't seem like such a big deal because you'll know what's happening. We group the terms together, we just simply perform this subtraction. Okay, that's it. Then for the rest of these, we just do the operations in order. This is a positive 4d, but then we're subtracting 2. So 4 minus 2 is just 2. And it's a positive 2 because positive 4 minus 2 is positive 2. So we put a plus sign here, 2. The d comes along for the ride because we add or subtract like terms, the variable comes along for the ride, right? This is like 4 dogs minus 2 dogs plus 8 dogs. So the 4 minus 2 is 2 dogs, but the plus 8 still had to happen. Then we had 2 dogs plus 8 more dogs became 10 dogs. And of course the sign was positive because this carried through. Then we can just flip the order of the answer to put the variable term first. All right, we only have 3 more problems. I promise they're not going to be that bad, but this kind of thing just becomes more clear as we do more things, more problems. 24 golf balls minus 18, let's say, minus 8 more golf balls plus 25. Where are my like terms? Well, the 24 golf balls and the minus 8 golf balls, these are like terms. And then the negative 18, the minus 18, and the positive 25, these are like terms. So let's take a moment to put them right next to each other, right? So we're going to have the 24 golf balls from here. Now this like term, let me move it right next door, including its sign or its operation, negative 8g. Then the constant term, including its negative sign here, negative 18, and then the 25, including its sign, 25. Just rearrange the order, including the signs. Now, what do I have? Look, I already have a typo here. When I rewrote this down, I was careless. See, this happens to everybody, right? It's not 2g, it's 24g. And it's not 8 here, or it is 8 here, sorry, that's correct. And then the 18 is there and the 25 is there. You know, I could edit this out of the video, but I really want you to know that I make mistakes too. What you need to do is show every step. That way, when you look back at what you did, you'll know if you made an error or not, just like I caught mine, right? I'm checking my work all the time and I saw, oh wait, I wrote that wrong. So the 24 from here, the negative 8g from here, the negative 18 from here, the positive 25 from there. Now, combine like terms. We have 24 minus 8. What is 24 minus 8? It's 16, but it's 16 G's, right? Because it's 24 golf balls minus 8 golf balls. It's got to be 16 golf balls. You have to carry the variable with it. All right? And then we have over here, minus 18 plus 25. Now that might look a little confusing to you, but because we're going to learn how to deal with negative numbers later, what I want to do now is just change the order of it in order to make it a little easier. What we'll do is we'll write the 25 first and then the minus 18 last. Then we know how to do that kind of subtraction. You see, I haven't really taught you what to do when you have like I have here, a negative number plus a positive number. We're going to learn that later. For now, just know that you can rearrange any additions and subtractions, and you'll always get the same answer. So all we did was we took this 25, moved it in front, and the minus 18 we moved in the end, and now it looks like a normal subtraction to you. And so you can say 16g, what is 25 minus 18? And that is 7. Positive 25 minus 18, positive 7. So you get 16g plus 7. That's the final answer. All right. Doing well. We're almost done. Let's take a look at 12x plus 6x minus 4 plus 16. Now you see why we don't use x's for multiplication symbols anymore, because we have x's running around our math. And so now we know that this means 12 times the thing that we're calling x, plus 6 times the thing we're calling x. X could be the number of marbles in your bag. 12 marbles plus 6 more marbles. We can add those together. They're like terms. They're already right next to each other. 12 plus 6 is 18, so it's 18, let's say, marbles. Right? Now we have the same problem going on over here. We have negative 4 plus 16, but I haven't really taught you what to do when you have a negative 4 plus 16. We're going to learn that later. So for now, just rearrange the order of it. We can take the plus 16 and put it first. We can take this minus 4 and put it at the end. We can arrange them as much as we want as long as we carry the operation in front of it, and we can make it look like a subtraction we know how to do. All right? So now, of course, you can say 18x. What is 16 minus 4? It's going to be 12. And it's going to be positive 12 because positive 16 minus 4, of course, is positive 12. So we get an answer of 18x plus 12. All right, we have one more. Let me see how big it is. Maybe we can fit it down here. Maybe we'll move along. I think we'll just squeeze it right down here. Let's take a look at 19 plus 6 minus 15 times m. And then we have plus 32m. All right, so here we have 15 monkeys, let's say, and then we have, with a minus sign, minus 15 monkeys, and we have plus 32 monkeys, right? So the numbers are going to be easy. We know we can add these, but this is going to be tricky because you have minus 15 plus 32. I haven't taught you how to take a negative, this is a negative number, negative 15, and add it to a positive 32. So here in the beginning, when we're just learning, since we don't know some of those rules yet, let's just change the way it looks to make it something that we can do. We know we can rearrange the order. We can make a positive 32m here, and this minus 15m can go at the end, right? Because you can move them around as long as you take the operation or the sign that's right in front of it, like we did right there. Now it's much easier because we know that these are like terms. 19 plus 6 is 25. Right? And now we have 32 monkeys minus 15 monkeys, and that's going to work out to be positive 17 monkeys. Positive 32 minus 15 gives you positive 17, and we're talking about monkeys. And so we have 25 plus 17m, and we can flip the order anytime we're adding, so we can put the variable, the term with the variable first. So 17m plus 25, and that's the final answer. So in this lesson, we really have started a journey. And so I want, number one, for you to pat yourself on the back because you got through it, and number two, to look forward to the future. We're just starting a journey here. When students see numbers and letters together, oftentimes they freeze up and just throw their pencil down and say, I can't do it. I mean, I actually used to be one of those students. It really frustrated me. So that's why when we do these 10 problems, I'm choosing them very carefully to show you different cases of what you're going to come across. From the easy things in the beginning, where 4 plus 2 is 6, and the variable comes along for the ride because we add like term to like term. Only positive signs at first, right? Then we have some negative signs, and I'm teaching you that we can move the terms around to make it easier. And then I get into situations at the end where if you don't move the terms around, you don't know how to take minus 4 plus 16, because this is really like a negative 4 plus 16. I really haven't taught you how to do that yet, but by rearranging them, you can put them in an order that you can then do, right? And so I've tried to choose these carefully to get that across to you. And this stuff is foundational. We use it for everything. We use it for solving equations, which we're going to do very, very soon. in the next few lessons. We use it for graphing. We use it for all higher levels of math. It really is the foundational steps. Combining like terms is used constantly. So please get your pencil out. Solve every one of these. Start at the beginning. Solve every one of these yourself. Make your own decisions. If you're not sure, then just hit play again, see what I did, and then file that away and use it. And over a lot of practice, you will get better. I promise you. And eventually, at the end of the day, you will get so that when you look at things like this, you'll know what to do because you've seen it so many times. That's the only way any of us learn. So practice them yourself. Follow me on to part 2. We're going to get a little more practice with combining like terms.